Your vehicle is equipped with a computer and diagnostic software that manages all aspects of the engine's fuel delivery, ignition timing, and emissions control. Sensors communicating with the computer and its diagnostic programming continually monitor various engine control systems, determining whether the vehicle is operating as originally designed. Together, this process and system are referred to as the On-Board-Diagnostic System, or OBD. The On-Board-Diagnostic System primarily consists of software designed into the vehicle's computer that detects emission control system malfunctions as they occur by monitoring virtually every component and system that can cause an increase in tailpipe emissions. OBD diagnostic software monitors engine performance and emissions whenever your vehicle is operating and alerts you if conditions exist that could allow emissions to exceed 1.5 times the level the vehicle was EPA certified for. To better understand what the onboard diagnostic system is controlling and monitoring, let's review actions that continually occur in your car's engine. During regular engine operation, a mixture of air and fuel is drawn into the cylinder. The mixture is compressed through piston movement and then is ignited by a spark plug. The air-fuel mixture burns rapidly, releasing energy, causing piston movement and rotation of the crankshaft. The exhaust gases created then exit the cylinder through the exhaust valve. This cycle repeats itself in all the cylinders hundreds, even thousands of times per minute. Creating the correct air-fuel mixture for proper combustion in the cylinders during all engine operating conditions is accomplished by the air-fuel management system. Many of the system's fuel delivery components, including the fuel pump, fuel lines and rail, and fuel pressure regulator, are used to deliver a pressurized fuel supply to the fuel injectors. Fuel injectors are electronic solenoid valves that are pulsed open and closed many times per second. When the injector is energized by the computer, the valve opens, allowing the pressurized fuel to be sprayed through a small orifice. The computer controls the air-fuel mixture being burned in the cylinders by adjusting the amount of fuel passing through the fuel injectors. When more fuel is needed to accelerate or climb a hill, the injectors are energized longer and more fuel enters the cylinders. The computer uses information from several sensors to precisely control the amount of fuel entering the engine, resulting in low emissions and good performance. The mass airflow sensor signals the computer about how much air is entering the engine at any time. The computer uses this primary sensor along with other sensors that measure intake air temperature, engine temperature, and driver demand to calculate the proper amount of fuel to inject. An oxygen sensor is located in the engine exhaust to verify the air-fuel mixture was properly burned, resulting in the best performance and low emissions. If the signal from the sensor indicates the oxygen content in the exhaust is low, too much fuel is being injected, and the computer shortens injection pulse duration, reducing fuel to correct the air-fuel mixture. In a similar manner, too much oxygen in the exhaust indicates not enough fuel, and the computer lengthens injection pulse duration, adding additional fuel. This feedback correction can occur from 10 to more than 100 times per second. If the computer detects a problem with one of the sensors and cannot adequately control the air-fuel mixture, it will turn on the check engine light. This lets you know that a fault has been detected. Your vehicle's ignition system needs to reliably provide a properly timed spark, igniting the compressed fuel and air mixture in each of the engine cylinders whenever it's running. A strong spark of adequate duration that completely burns all the air-fuel mixture in the cylinder is critical to the proper and safe operation of the catalytic converters. If incomplete combustion of the fuel in a cylinder occurs, the remaining fuel passes into the converter and continues to burn there. This event is called a misfire. Misfires can be caused by lack of proper spark, incorrect air-fuel mixture, or a problem with the actual cylinder. When an engine misfires, the catalytic converter has limited ability to properly handle the extra unburned fuel, and some of it passes out the exhaust as pollutants. If the catalytic converter continues to be exposed to unburned or incompletely burned fuel, the converter can overheat and suffer internal damage, reducing its ability to reduce exhaust pollutants. The computer continuously monitors for misfires through various sensors. Oxygen sensors monitor the exhaust gas leaving the cylinders. During a misfire, the oxygen in the air-fuel mixture passes, unchanged, through the cylinder and causes a spike in the oxygen sensor's reading. At the same time, the crankshaft speed sensor monitors engine speed, and a momentary drop in engine speed confirms the misfire. A NOx sensor attached to the engine block detects vibrations in the engine caused by certain types of misfires. When the computer senses a significant misfire, it will turn on the check engine light, letting you know that a fault has been detected. When the combustion cycle is working correctly in all of the cylinders, maximum engine power is achieved, and the resulting exhaust gases contain small amounts of pollutants that can readily be cleaned up by a catalytic converter in the exhaust system before exiting the tailpipe. Proper catalytic converter operation and high converter efficiency are essential to achieving low exhaust emissions from your vehicle. As one or more converters age or are exposed to excessive unburned fuel in the exhaust, their efficiency or ability to clean up pollutants diminishes. To test for this, the On-Board-Diagnostic system monitors the converters whenever the vehicle is operating under normal driving conditions. The On-Board-Diagnostic system uses the oxygen sensors in the exhaust system to monitor the converters. An oxygen sensor measures the oxygen content of exhaust gas. When the catalytic converter is working, some of the oxygen in the exhaust gas plays a role in cleaning up the pollutants. The upstream oxygen sensor installed before the converter and the downstream oxygen sensor installed after the converter are used by your car's computer to measure changes in the exhaust gases caused by the catalytic converter. As your car ages, the efficiency of the converter diminishes and the electrical signals from the oxygen sensors change in a predictable manner. When catalytic converter efficiency drops below an acceptable level, the computer turns on the check engine light and sets a diagnostic trouble code. A primary task performed by your vehicle's computer and onboard diagnostic system is to make sure all the engine sensors are working properly and that the engine isn't polluting. The computer uses input signals from a wide variety of sensors and switches to regulate spark timing, fuel delivery, and other emission functions. If a sensor fails, reads outside its normal range of values, or can't send its signal back to the computer because of an electrical issue like an open or shorted circuit, engine performance and emissions output will be affected. In a similar manner, the computer has to be able to properly control many system components, including the ignition system, fuel injectors, evaporative emission solenoid, and other control devices. If the control commands can't get through, performance problems and higher emissions will result. Monitoring of these tasks is accomplished through the computer's onboard diagnostic software. Whenever the engine is running, the OBD system continuously checks for the simple types of faults just described. It also checks most engine functions while the vehicle is being driven. The onboard diagnostic system even executes a series of complex diagnostic routines that run during specific vehicle operation conditions. These routines, called readiness monitors, exercise the various emission systems and check for expected results. After the OBD system has run a monitor, the results are compared with a set of expected results. If the results are the same, the monitor passes, and if the results are not the same, the monitor fails. These types of tests enable the onboard diagnostic software to detect engine misfires, how well the catalytic converter is performing, and whether the vehicle is leaking fuel vapors into the atmosphere. With the onboard diagnostic system in your car, almost any vehicle system problem that causes emissions to exceed the federal limit will cause the check engine light to be illuminated, even if there is no noticeable change in how the vehicle drives or performs. To find a AAA-approved auto repair facility near you, visit AAA.com/auto repair.